All right. Hey, here's what we got. We got section 4.3. This is increasing and decreasing intervals. This kind of ties into what we did in 4.1, which is finding relative and absolute max and mins, because where intervals increase and change to decreasing is where we have a maximum, and where we have a decreasing function changing to an increasing function is where we have a minimum. Okay, so how do we look at this? Well, we're going to look at something called the first derivative test. Okay, and what we did in the past is we wrote our work using a t-chart with x and f prime of x, and we found our x values first by setting our derivative equal to 0, because that's where maximum and minimums occur of some nature. And then we found out what x was. Okay, we solved for it. Okay, and we got these numbers, we inputted them in here, and we tested items that were slightly lower than it and slightly higher than it. And we looked at what those values were with respect to f prime of x, whether they were positive or negative. And if that happened, then that would suggest that we had, maybe in this case, a maximum of some type, because we went from positive values to negative values for our derivative function, okay, that surrounded this respective x value. Same idea here. They're looking at a derivative function here. You can see it's called f prime of x. I'm going to underline this so you can see it. And the idea is that when you have your critical value c, okay, which we identified over here with an x, okay, this does look like this is a minimum, okay? And the idea is this, is that as you're moving in this direction here, okay, these are values that are less than 0, okay, because these are slope values that are less than 0. And so if you have slope values that are less than 0, that means that you are decreasing. Right? And then when your f prime of x is bigger than 0, that means you are increasing. Okay, now this is, I believe, the function f of x, okay, but nevertheless, when you're reading this, what's going on here, this is the explanation of your slopes of f of x, in this case going downwards because they're less than 0, or your slopes going upwards, okay? So in the end, this is my interpretation of f of x, but the idea of this decreasing is what f prime of x is, okay? Saying that you are decreasing, or your slopes are negative, okay? Slopes of all these tangent lines are negative, they're going down, whereas these are going up, okay? Similarly, this is still an f function. Let's call it f of x. And the idea is that you have positive slopes, okay? And that's what this is. This is a derivative or a slope function, okay? And then the same thing here. This is also a slope function. And when your slope function is bigger than 0, that means it is positive. And when your slope function is less than 0, that means it is negative and it's going down. Okay, and so this part, of course, is still increasing, and this is decreasing. Okay, that may be tough to read, but as I share that, it should make sense. Okay, and then sometimes you have these c values that when you take the derivative on each side of it, you'll notice the sign won't change. Maybe you do this work off to the left, and remember that when we do find a critical value, it's either a derivative set equal to 0, or it's when it's undefined. Okay, and sometimes you see that happening when your signs are the same. Okay, so if you have an x value where it's undefined, you're certainly going to write that. Okay, however, make sure you do the testing for it and see what happens on each side. And sometimes when the signs are the same, okay, like maybe you see that here where both your f prime of x is positive for the part to the left of, or the lower than part of your value for c, as you input it into f prime of x, gives you the same sign as the right side, okay, the more positive end of that. So maybe they're both positive. And that's the case. It's not going to be a max or a min. It looks like it may be maybe a point of inflection. We'll have to see. Okay, so sometimes that happens where your critical value may be undefined, okay, because of an asymptote or an undefined point, you never know. And in that case, your f prime of x may not change sign from positive negative values or negative positive values as you reach this critical value from each side. Okay, so we'll look at that as we look at a couple of problems. And you can't see one of my questions here completely, so I'll move myself. I didn't mean to make myself bigger. But I'll put myself up here. Awesome. Okay, so it says find on an open interval on which f of x equals x cubed minus x squared, whether it's increasing or decreasing. And then part B, kind of going on the same line, says find any relative maximum or minimums for the function. Okay, notice there is no boundary. Okay, I don't have a bounded interval. It just says in general where our relative maxes or mins. And as you look at this, this is a cubic. So we kind of know what that looks like in terms of this left-hand and right-hand behavior. But what we'll do is we'll treat this like we would any other problem. We will find maxes and mins, take our derivative, which is 3x squared minus 6x. Okay. And what I'll do is I'll set this equal to 0 because maxes and mins have tangent lines that are 0. Okay, and so that's what would happen here. This is my derivative function. This is my slope function. I want to know where my slope 0 is because that's where maxes and mins are. And so I will factor out something they have in common, and it looks like not only a 3 factors out, but an x will also factor out. And if you pull out both a 3 and an x, you're left with x minus 2. And we'll set each one equal to 0. And so I get x equals 0 and x equals 2. Okay. All right, so what does that mean? Well, first they're asking about where things increase or decrease. So it's a slightly different question, even though kind of conceptually they all blend together. Okay, so I'll treat this the same way as before. I have values at x equals 0, where I got a derivative of 0. And at 2, I also got a derivative of 0. All right, and let me use a different color here so we can separate what these items represent. And so let's pick something a little bit smaller than 0, like maybe -1. And something in between the 0 and the 2, like a 1, and maybe a 3. All right, so what does this mean? Well, I can take this -1, and I want to figure out on the left, basically the left side or the more negative direction of 0, what's going on with f prime? What's going on with the slopes there? And I can plug -1 into a couple of spots. I can plug it into this first one or this second one. Sometimes if you have a big polynomial and you're trying to do this quickly in your head, the factored one's a little bit easier. So if I take 3 times -1, that's -3. And if I take -1 minus 2, that's also -3. And so -3 and -3 give me a +9. Okay. So what does that mean? It means anything to the left, okay, or in the more negative direction of 0, okay, I have positive slopes. Okay, and what does that suggest? It suggests that it's increasing. So from anything to the more negative direction, so I'll say from -infinity to 0, it'll be increasing. Okay, and I'm not going to include 0 at this spot because it's not really increasing at 0. Okay, that's the spot where we change from increasing to maybe something different. So let's plug in 1 now into this, and 3 times 1 is 3. 1 minus 2 is -1, so that will give me -3. Okay, and what does that mean? Well, if it's negative, then it must be decreasing. Okay, and where is it decreasing from? Well, at 0 to 2, you should always get negative values. Any number between 0 and 2, not including 0 and 2, should give us a negative slope or a negative result when we plug it into our derivative function here. Okay, it'll always be negative, so which means you'll always have a negative slope, which means it's decreasing. And then finally 3, when you input that into our derivative function, 3 times 3 is 9, 3 minus 2 is 1, 9 times 1 is 9. So it is increasing. okay, from, well, 2, and then anything higher than that. Any number you plug in that's bigger than 3 is going to make both this piece, that I'm underlining underneath here, 3x, and this piece, they'll both be positive. Okay, and positive times positives are still positives, which means you're going to have positive slopes, okay, for those. Okay, and so that's your answer. That's where everything increases and decreases. And then once you've done this, it makes our next part pretty easy. Okay, so all I'm going to do is identify x equals 0 and x equals 2. And what's going on at 0? Well, you go from increasing slopes to decreasing slopes. And so when you go from increasing slopes to decreasing slopes for f of x, okay, then what that means is you have a max. Okay, so we have a max. I'm going to say a relative max. I'll abbreviate that. Okay, since we move from positive to negative values, and for f prime of x at x equals 0. Okay, so a couple things here. We move from positive values, okay, these are positive values, to negative values for f prime of x. Okay, so make sure you use the function that we're talking about in terms of our t-chart, and then recognize that these are just values, okay? They are not slopes. They are slopes for f of x, but not the slopes for f prime of x. That would be like a double slope, okay? All right, and then the same thing for x equals 2. We will say we have a relative, and the idea is we're going from negative to positive values for your slope. So negative values to positive values for your slope. So that is a relative minimum. Since we move from negative to positive values for f prime of x at, x equals 2. Oh, that was way too fast. Okay, so again, this part here, which is kind of like the new piece, kind of helps us identify what we did previously, all right? I kind of taught this a little bit earlier because I felt like this was important in order to answer this one completely. And AP is very kind of rigid about making sure you explain why things are maxes and mins, okay, with respect to this type of, it was a conversation, but this type of support, okay? So, all right, let's keep going. All right, it says find the relative extrema, okay, for this function, and you can see it's not as clean as the ones we've done in the past. Like, oh no. Nevertheless, what we'll do is we will do what we've done for every one of our extrema. Remember, extrema is a form of critical value, okay, and so the undefineds may not be of significance to us here, but let's take the derivative of this. This is f prime of x is equal to, and we'll do a power rule. So 3 times 2/3 times x squared minus 4 to the negative 1/3. Okay, and then times on the inside for your chain rule is 2x. All right, so let's see, 2x. Well, those 3's are going to go away. Times 2 is going to give me 4x. And then I've got x squared minus 4 to the 1/3, and that is a negative. And that just leaves me with 4x over x squared minus 4 to the positive 1/3. Okay, so what does that mean? Well, it means a couple things. First, where is x going to give me a 0? So where is f prime of x equals 0? Okay, that's kind of my question here. Well, it's basically when your numerator is 0. Okay, so if you take 4x instead of equal to 0, your x is 0. And then remember, critical values are also where things are undefined. Okay, so I may not have maxes and mins there, but I can certainly find some other things that are of value. So what I'll do is I will take this denominator where I would get some undefined values, and that's all to the 1/3. That didn't go away. Set that equal to 0. So x squared minus 4. Here's what you can do. To get rid of this 1/3, you can take both sides to a power of 3. Okay, and 0 to the 3rd power is still 0, but at least it cleared out this 1/3. And the rest kind of goes pretty easy. You're like, oh, I can solve that, no big deal. And so I also have plus or minus 2. Okay. All right, so big T chart here. I got a lot of stuff. Okay, and like always, I have x and f prime of x. 0 is right down the middle, and 0 gave me 0 for f prime of x. Other pieces that were important were -2. And it didn't give me 0, it actually gave me, if you take -2 and plug it into this guy, the part I'm boxing right now, you're going to get a 0 in your denominator, so that's going to be undefined. And the same thing with +2, that would also give me an undefined. All right, so let me pause there for a second, and we'll show why it's important to write these undefined terms in, because when you look at 0, maybe that's our only form of extrema, it doesn't mean that, in terms of our relative 1, it doesn't mean that things can change from the left side to the right side, okay, if we don't identify our undefined values. Okay, so let's take a look at my derivative formula, and I'll use a different color here. I'll use purple, and here it is. Okay, I'm putting that in a box, and we'll look at some things. Let me start with some things I think are easy. Input values of 1. If I plug in 1 to the top, I'll get a 4. And when I plug in 1 to the bottom, 1 squared is 1, minus 4 is -3. And -3 to the 1/3 can be worked out, but I know it's going to give me a negative value in the end. And am I going to work it out? I could in my calculator, but I don't really have to. I just got to know in the end that after I write this out, I'm going to get a negative, okay? Because a -2, a cube root will still be a negative, just like if I said, hey, the cube root of -8, I know that that is -2. I know this is some ugly fraction, but in the end, I know it's negative. Okay. All right. Let me pick another number. I think maybe easy, 3. When I put that into the derivative function, 4 times 3 is 12. All right. And then 3, when I plug this in here, 3 squared is 9, minus 4 is 5. And I've got 5 to the 1/3. Do I know what this is? No, and I really don't care, because in the end, it's simplified enough where I know it's positive. Okay, there's no negative signs in our problem. All right, so let's do another one. Let's do -1. And now 4 times -1 is -4, so that will give me a negative on top. And then -1 squared is +1, minus 4 is a -3. Same thing that you had here, -3 to the 1/3. And again, regardless of what that simplifies to, I know the negative of the negative will give me a positive value. Okay. And then finally, what's less than -2? How about negative? Pick anything we want. Let's pick -3. But that gives me -12 on top, like I had before, in the sense that I had another negative here. And then let's see, -3 squared is 9, minus 4 is 5 to the 1/3. Okay, and again, the idea is that a negative over a positive is a negative. Okay. Now, again, I don't know necessarily what I have at -2 or at +2. Sometimes it's sometimes you have asymptotes there, sometimes you have holes, sometimes you just have the crooked corners, okay, and you just don't have a derivative at that spots, okay. And as I look at this first one, the original function, it looks like it's that, okay. There's nothing that x can't be here. This is completely defined. However, my guess is that there's some type of crooked sharp turn, okay, at -2 and positive, which makes it not differentiable at those two spots, because this is certainly continuous. Okay, there's nothing that you can put in for x that won't give you an output. Okay, okay, so here's what I'm going to do. All I have to do is identify the extrema, and I have to know that x equals 0 is something important. And at 0, okay, I go from positive values to negative values. So positive values to negative values for my f prime of x, which means I have a relative max. Okay, so I'm identifying this one here. Okay, at x equals 0, because we move from positive to negative values for f prime of x at x equals 0. Okay. All right, now these here, okay, my guess is that -2 and +2 will also be some form of extrema, okay? It may not be differentiable there, but they could still have a max or a minimum at those respective spots, okay? In fact, if you plug in your calculator, okay, you may notice that that actually works and does that, okay? So here's what I'm gonna do. I'm gonna pause this just for a second, and then I'm gonna see if you can put this in your calculator, just the original, and just verify that we have maxes and mins at -2 and +2. Okay, and again, they may not be differentiable there. They may be sharp turns, but I want you to see if you can observe that. Okay, so let me put a pause here for a second for me and for you, and I want you to check it out. Okay, plug that into Y1, see what you get. Okay, so here's what I'm going to do. Hopefully you put this in your graphing calculator, got to see what you believe is the correct thing. And I'm going to get out of my PowerPoint just for a second to see if I can show you my graphing calculator, which I have on my TI emulator. And so I'm going to escape this just for a second and go to my TI graphing calculator. La-di-da. Okay, so here if you go to my y is equal to, you can see I typed in the equation just like you have. Okay, and if I hit graph, I do get this. Okay, so at x equals 0, we found the max. Okay, and you can see down here, it looks like at these two spots, -2 and +2, they do look like minimums. Okay, and there are locations there. They're not open circles. In fact, you know, if you look at the original equation, if you plug in 2 here, you get 0 in this parentheses. Okay, if you plug in 2 for x. But 0 to the 2/3 is just 0, times 3 is still 0, and so it just means that 2 zeros a point and -2 zeros a point as well. But I just wanted to give you perspective of that graph before we moved on. And so yeah, even though we have derivatives that are represented as undefined, okay, yeah, there's no derivative at this spot here, but it does represent a maximum or a minimum, and it looks like this case is a minimum. So let's go back to our chart and we'll see what we have. And I will light this up so it looks like a regular PowerPoint, and we'll finish it. Okay, so I can say the same thing for both -2 and +2. I can say at -2 and +2, we have some relative mins. And not because I cheated and looked, but because it gave me some ideas with respect to this t-chart. Okay, and so what I'll say is we moved, okay, from negative to positive values. Okay, for f prime of x, okay, at both, okay, x equals 2 and x equals -2. All right, so these undefineds come into play. You cannot just avoid those. All right, and so while we understand that there are no derivatives there at 2 and at -2, that doesn't mean that we don't have max or mins at those locations. All right, so keep that in mind as you're working through your first derivative. People nail this one all the time. They're like, that's no big deal. But can you also look at your function for your derivative and say, hey, where may this also be undefined? And if you can identify those, like we did here, then you come up with some additional answers. All right, awesome. All right, let's keep going. All right, find the relative extrema for h of x, and I have x squared plus 1, sorry, x to the 4th plus 1 all over x squared. Okay, now some people try to simplify that, and they write it like this, x to the 4th over x squared plus 1 over x squared. You can do that if you want. I think for myself, I just did a big old quotient rule, just because I kind of like to do that. Okay, so h prime of x is, let's see, low times the derivative of the high, and that gives me 4x cubed. Okay, minus the high, all times derivative of the low, which is 2x, all over low squared. All right, so h prime of x gives me x to the 4th on the bottom. Okay, on the top, gosh, if I combine those, that looks like it's 4x to the 5th. And if I distribute that 2x to both of these with that subtraction sign, that is a negative 2x to the 5th minus 2x. All right, and so as that cleans up a little bit, and it's not a whole lot, but I can combine my x to the 5th. So that's 2x to the 5th minus 2x. And I suppose if I want to make this look a little bit better, I can break this up into 2 parts. Okay, and let's see what happens. Well, it looks like this x to the 5th and those x to the 4th, that'll cancel out, just leave you with an x. And this will give you 2 over x cubed. And I'll set that equal to 0. And so I will move this over to the other side. Kind of like that. And I can cross multiply if I want. So let's see, this will give me 2 is equal to, let me move this up here, 2x to the 4th. And we'll keep going. Let's see, divide both sides by 2, I get 1 here, x to the 4th. And I can square root both sides. So, and if I square root both sides, I will get plus or minus 1 here. And, well, x squared, I guess I'll get that. And then in the end, just long story short, you're going to get this. Okay? I'm not going to worry about the imaginary values. All right. Also to keep in mind that once you take the derivative, you do have one value that is undefined. So it's important to note that at x equals 0, you will get an undefined, even though we were able to get things to cancel out. Okay, the first derivative will simplify to give you something that looks like this. Okay, I'm going to put a little star by it so you can see it. And here, again, x is undefined at 0. So we will make another t-chart. This is h, sorry. You know what I did? I'm going to go back a screen. I put F here. 3. Should have a G there. Sorry, G's. That's kind of funny. G's, I should have had G's here. Okay. I think messing up on that was worth the pun. Okay, so I'm going to keep it there. I'm not going to start this over. So, all right, so there's h of x, h prime of x. And so I'm going to have 0, which is undefined. We'll see what happens there. I've got a -1 and I've got a +1. These are both zeros. and I've got to find what's happening on all those sides. Okay, so I got to pick something a little bit lower than -1, like maybe a -2. Something a little bit bigger than 1, like 2. And something between -1 and 0 and 0 and 1, like a half, and I'm not really excited about either one of those. Okay. Nevertheless, if you have ugly numbers like this, know that you can take this h prime of x, put it in your TI-84, okay, and then from there, just plug in the numbers. Just say, hey, I'm going to let my y1 be equal to this. Okay, actually do the more simplified version. Maybe even this one better. Sorry. Okay, let that be your y1. Okay, and then plug in all these numbers, okay, and see what happens. Now, I did that already, so, but you can do that. You can plug this into your graphing calculator and just do these super fast. So when you plug in -2, you get -3.75. Okay, you plug in -0.5, you get 15. When you plug in +0.5, you get -15, and 2 gives you a +3.75. Okay, and again, not that they asked this, but where is it first increasing and decreasing? Well, it looks like from -1 to infinity. Okay, so from -1 to infinity, which is negative out here, you have negative values, so this is decreasing. I'll just put a D for now. From -1 to 0, you have positive values for your slope, so that means it must be increasing from these two intervals, or within that interval, from -1 to 0. Okay, it looks like from 0 to 1, you have negative representations for your h prime of x, which means that is a decrease. And then from 1 to, which would be infinity way out here, it is increasing. Okay, so let's write a collection of answers for both relative maxes and relative mins. Okay, and who knows, some of them may actually be absolutes, but for now it just says find the relatives. Okay, it doesn't say which ones are the most extreme one way or another. Okay, so we agreed that, hey, when we go from decreasing to increasing values, that would be a decreasing to increasing a minimum. So we have a minimum at x equals -1. Okay. Here you go from increasing to decreasing at 0. So increasing to decreasing at 0. So we have a relative max at x equals 0. All right, and then we have another moment where we have decreasing to increasing, and that is again another relative min. Okay, so I'm just going to put that right next to it, at x equals -1 and at +1. Okay, and then we'll write our support for that. We'll say we move, or a little differently, I'll say f prime of x moves from decreasing to increasing values as x equals -1 and x equals +1. Okay, and then for relative max, the reverse happens. Okay, for f prime of x, we move from increasing to decreasing values at x equals 0. Oh, sorry. Okay, so that's how that finishes. Same type of work, okay? I put these in, not that they ask for it, but sometimes it helps organize my thoughts in terms of how I write this script at the end, okay? Again, use your graphing calculator if you need to help you out, okay, in terms of getting an idea of what your picture may look like, either for the original function or maybe just for the derivative, okay? All right, last one. And you can't see it because I'm hiding it. Let me move myself. Okay, so use the first derivative test to find the extrema, okay, which is what we've been doing. And so again, I'm gonna take the derivative f prime of x. Now, first time we've had trig, okay? This derivative sign is cosine of 2x, okay, times the derivative of 2x, which is 2, okay, minus the derivative of 1x is 1. Okay, so I'll set this equal to 0. This is 2 cosine of 2x minus 1. All right, and then we will solve. Now, we'll be careful when we do this. I'll show you kind of my algebraic way of doing it. I'm going to add 1 to both sides. Okay, and I'm going to divide by 2. So you're kind of like solving for the trig function, if that makes sense, without all the fluffy stuff like the amplitude and the shifting to it. So, okay, and you got that. And once you get there, it's not bad. Okay, now here's what I'm going to do. Let me write it the normal way so that the cosine and the angle's on the left side and the ratio is to the right. Okay, and for a second, let me cheat. Like, what does that mean to cheat? Let me just call this instead of 2x. Can I call it something else? Let me call it y. No. Let's call it b. Okay, so basically 2x is equal to b. Okay, and if I asked you to solve for b here, you'd say to yourself, well, I know unit circle pretty well. And let's see, cosine is positive in quadrant 1 and quadrant 4. Okay, where these are right triangles. And I intentionally didn't draw them the same, just so you can see them a little bit more easily. Okay, I know that's mathematically not sound, but I'm hoping you'll humor me with that, just because I want you to be able to read it well. But the idea is that cosine is adjacent over hypotenuse. That is the ratio. And so from our angles here near the origin, cosine, and I'll call this b. The cosine is adjacent, which is 1 is down here, and the hypotenuse is there, it's 2. And that means this third side is the square root of 3. And again, it's not drawn on the scale, but that's okay, all right? Because it's just a little baby graph here. Okay, so what is b? Well, what angle gives me the opposite side equal to the square root of 3? Make it 60 degrees, or pi over 3, which is the way they like to see it written in this class, pi over 3. And what about this one over here? Well, this b, if it were in the fourth quadrant, also has a side of 1 here and opposite of 2. And this side here is negative square root of 3. But that's okay, because in the end, all I have to know is this angle measure, okay? And while the first one was pi over 3, if I stretch this all the way around to get to the hypotenuse there, it would give me 5 pi over 3. Okay, now, most of you would say, do I stop? And you can, okay, when you have typically just a b here, or just like this x. There we go. Okay, if you just had that b there. But since really I had 2x, okay, representing that angle, you have to do 2 oscillations of this, okay? So what I'm going to do is I'm going to include another oscillation of this, okay, of this curve. And so the first one was pi over 3. If I add 2 pi to that to make my second circle, that would be, well, it would be 2 1/3 pi, which is the same as 7/3 pi. Okay, and if I add another 2 pi to this, gosh, let's see, that's 5 pi over 3. Let's make this easy. If I add 2 pi, that's the same as 6 pi over 3, so that's 11 pi over 3. Okay, and you're like, am I done? I'm like, you're almost done, okay, in terms of finding your relative max and mins here. And they say extrema, so that could be absolutes, but we'll see. And what I'm going to do is this. This is just what b is. This isn't really my answer. I need 2x. Okay, so what I'm going to do is replace my b with 2x. So I still have pi over 3. I've got 5 pi over 3. I've got 7 pi over 3 and 11 pi over 3. But I'm now going to set it equal to, not b, because I'm not solving for b, I'm only solving for 2x. Darn it. Okay, so what I'll do is I will divide everything by 2. Okay, and so that way I'll get x by itself. So that will give me pi over 6. If I divide this by 2, that's 5 pi over 6. And the next one will be 7 pi over 6. They're all going to be over 6, I guess. And then 11 pi over 6. Okay, and again, you have to do 2 sets of these. Okay, so when I did this b, and I'm like, why do you have to do 2 sets of them? Well, basically your periods, your angle here is doubled. Okay, and so if your angle is doubled, it means you'd have 2 sets of answers. Okay, 2 pi divided by b is 2 pi divided by that 2, which is pi. So your period is pi, meaning one oscillation will go, of your picture, will just go from a length of pi, but again, we like a full 2 sets, okay, to make our full unit circle. All right, last piece. Then we do this, we're done. You're like, this may not be pretty. I've got 4 of these. And you're right, we got 4 roots. Okay, I'm going to start with pi over 6. I know that gives me a 0. Leave a little space. There's 5 pi over 6. That also gives me a 0. 7 pi over 6 gives me a 0. And 11 pi over 6. That gives me a 0. All right, so what does that mean? Okay, that's where all my max and mins are. And I keep wanting to just finish this off. Let me use a different color here. I'll use red. And I'm going to pick some numbers that are a little bit smaller. Okay, so in this case, a little bit smaller than pi over 6. I'll just pick 0. What's in between these two? Well, kind of an easy one to do is just pi over 2. Okay, and what's in between these two that are nice? Maybe pi. And I can say 3 pi over 4 here. That would also work. And I think this last one I could probably just say 2 pi. And that's where things repeat. Okay, so, and then you'll plug it back into your original derivative function, which I think the most simplified version of that is right here. Okay, and you don't need nice clean numbers all the time. Sometimes it works, sometimes it doesn't, but we'll see what happens. You can just plug your calculator in. In the end, you just want to make sure that they're positive or negative. You figure that out. But let's see, if I plug in 0, the cosine of 0 is 2 cosine of 0 minus 1. Okay, so the cosine of 0 is 1. Okay, so times 2 is 1, minus 1 is 1. So it's positive. All right, if you pick pi over 2, which is halfway, maybe not exactly halfway, but it's, yeah, maybe it is. Somewhere it's in between pi over 6 and 5 pi over 6. Okay, plug that in. Cosine, now let's be careful here. This is 2 times pi over 2. It's really just pi. Okay, minus 1. And the cosine of pi is negative 1. Okay, so cosine of pi is negative 1 minus 1. So that will give you a minus 3. Okay, which of course is a negative. When you plug in pi, remember you're doubling it. So that is 2 cosine of 2 pi minus 1, which is the same as what you had earlier when you had that input of 0. It's the same as this. Okay, so cosine of 0 is 1, so 2 minus 1 is also 1. And 3 pi over 4. Now if you plug that in, let's be careful here, just to make sure we got this right. Okay, now 3 pi over 4 is not high enough. It's not going to work, actually. 7 pi over 6 is pi, and 11 pi over 6 is too much. Maybe it is okay. Let's see. Okay, so that's 7 pi. I'm tired, so hang tight. 7 pi over 6 and 11 pi over 6. I may have to plug something else in. I need something pi over 6. So how about 9 pi over 6? That would be okay. And that turns out to be 3 pi over 2. So I was close. Let's put a 2 there. Okay, so those will go away. And it's the cosine of 3 pi. And the cosine of 3 pi is the same as the cosine of pi. And cosine of pi is -1. So I have, again, -2 minus 1, which is a -3. And of course, this will be 1 again, because 2 pi and 0 will keep the same thing. Okay, now you aren't going to have absolute extremes because they're going to oscillate at the same amounts, okay? And you're just going to have the same maxes as you keep moving across, okay? And so what I would do for this is, if I'm going to talk about some relative maxes or absolute maxes, your maxes occur, well, let's see. They did here, and they did here, and they did here. But these are my roots. Let me do this. There's 1. There's 2. Okay. And so when you go from positive to negatives and then positive negatives, you have some maxima. So maxes occur at pi over 6. Okay. And it looks like we're adding pi every time. If I were to say, what's the difference between pi over 6 and 7 pi over 6? We're adding sets of pi. So if you were to add another pi to this, I'm thinking that you're probably going to get your next answer. Okay. So I'm going to write that. Okay, I'm going to say 7 over pi over 6 plus pi k, okay, where k is an integer. Okay. And if I were to say a min, okay, it's going to be this one here. Let me put a different color here. Blue. It's 5 pi over 6. Okay, plus, and again, there's another moment where you have a min. It's 11 pi over 6. So you're adding again from 5 pi to 11 pi, both over 6. You're adding another 6 pi over 6, which is another pi, plus pi k. Okay, where k is an integer. And now why do I have to say an integer? Because I don't know what k is. K could be a nice number, like I just said, like 1 or 2 or 3. It could be the negative versions of those. Or it could be, we could count it by 0.5s or 0.7s or a third. So I need to identify what I'm counting by. And as long as I say k is an integer, then every cycle, every oscillation of pi, you will get another, in this case, minimum, okay? And also here, a maximum. And so for now, I'm going to call these relative because they're really not absolute because there's not one, okay? It's just the same one that kind of repeats over and over and over again. So, all right. If you have any questions, holler at me. It's kind of the same as before, but I told you you're going to have some bigger problems, okay? Bigger work that is represented here. So, but nevertheless, holler at me if I can help you out. Thank you so much.